The conditional probability of an event is the probability that the event will occur, given the knowledge that a previous event has already occurred. We need to understand it first, before diving into Bayesian statistics. I'll explain everything you need to know about it in the next 5 minutes. Have you ever heard something like, "The weather is so nice today, there must be a lot of people in the park," or "Traffic will be getting better after the rush hour"? This all sounds very reasonable, but take a moment to think about where these conclusions come from. What is the logic behind them? Well, they are based on conditional probability. In probability theory, conditional probability is a measure of the probability of an event occurring, given that another event, by assumption, presumption, or evidence, has already occurred. The weather is good and after rush hour are both conditions. If I show you the word apple, can you guess whether it's referred to the company or the fruit? Without any content, it's really hard to say, so maybe 50-50. But what if I told you that I found it in a technical journal? Then apple more likely referred to the company. And then I added that it's a journal focused on agriculture. Well, in that case, we must believe apple probably referred to the fruit rather than the company. See, under different conditions, probability changes. Formula of conditional probability. Probability of A given B equals to probability of A and B divided by probability of B. Let's find out how to use it from an example. Say, in my neighborhood there are 6% of them have a dog, and 3% of them have both dog and cat. So, among those households who have a dog, what is the percentage they also have a cat? I have to say, all probability is conditional probability. You must agree that the probability of tomorrow's sunrise is 100%. Actually, the condition here is the sun's still there. Toss a coin. The probability shows each side is 50%. That's also a conditional probability. The spinning coin tends to fall towards the heavier side more often, so the condition is we assume the coin is perfectly even. When using conditional probability, you have to take extra care since it can be very misleading. You probably know the Simpson trial, the criminal trial of former football star Simpson, who was acquitted in 1995. District attorneys thought that they had a very strong case against Simpson. One evidence is the textbook example of domestic abuse. Simpson was represented by a high-profile defense team. They argue that domestic abuse and murder don't have a strong correlation. In the US, there are about 4 million domestic abuse victims. Among them, 1,432 been murdered, less than 0.04%. So, they can't use domestic abuse as evidence. Well, this argument sounds very convincing, since it's based on the statistic data. However, it is totally wrong, because they haven't considered one crucial condition. Simpson's ex-wife already been murdered, so it is not under domestic abuse the probability of murder, but should be under the condition of domestic abuse and wife being murdered, the probability of husband is the murderer. Based on the 1992 US statistic data, under these two conditions, there is 93% husband is the murderer. High-frequency trading, also known as HFT, is a method of trading that uses powerful computer programs to transact a large number of orders in fractions of a second. It is usually more profitable than the traditional method. As you know, there are a lot of things that can affect the stock market. It is extremely hard to predict based on all these pieces of information. However, if you only consider information within a very short time, then the conditions that affect the market tend to be simplified, which leads to more accurate prediction. 2 takeaways. First, essentially, all probability is the conditional probability. Second, the main purpose of conditional probability is to quantify the condition's effect. I'm always here at your service. See you in the next one.